Hello, everybody. Today we're going to talk about karyotypes. So we're going to be doing an online lesson on karyotypes in a little bit, but I think it's good to have a little quick explanation of what a karyotype is, why they're important, what information do they tell us. They've become very popular in the last few years as generally as people get older before they have children is where they come up for the most part. So a karyotype's basically a picture of all of your chromosomes in your cells arranged by size and their homologous pair. So they look at how many chromosomes there are. Do they have all the right genes on them? And how do they compare with the other ones? So they'll have your mom's chromosome and your dad's chromosome will both be in there if you were to do a karyotype of yourself. The last pair is set up as the sex chromosome. So a karyotype will tell us what sex the child will be. And it looks something like this. They are arranged by size. So you notice that number 1 here is the largest chromosome, and number 22 will be the smallest one. Basically by size, as it's larger up here and smaller down there. And then you'll have your sex chromosomes here, where the X will be very large and the Y is a small dinky right there. All right. Generally, when they do these pictures, they get the chromosomes in metaphase, so they'll have all this classic X shape of the chromosome. All right, now there is something that can happen with these karyotypes, and the reason that we look at them is because of a thing called nondisjunction. So basically, this is a problem in anaphase of meiosis. The chromosomes just don't separate properly. So it can happen either meiosis 1 or meiosis 2, and it will be an anaphase in both meioses. If it's in meiosis 1, all 4 cells will be affected, and meiosis 2 would only affect 2 cells. So basically, instead of pulling the chromosome in half, one side ends up pulling the full chromosome over, and so one side ends up with twice as many, and the other side is missing one. So often a non-disjunction situation, if a sperm and egg went through non-disjunction, it would be fatal for the offspring. They probably would not be born. They're missing a chromosome, or they've got too many of one. It just causes an issue. So as an example here, we've got, this would be a 4-end cell. You see it's lined up in metaphase, and then when it goes through anaphase, only one of the chromosomes was pulled over, so one of the larger ones were not, so that we end up with 2 cells that have a +1 to them because there's 3 here and there's only supposed to be 2, and this one is missing 1, so it's -1. So there's going to be missing chromosomes or extra chromosomes. Generally are a bad thing in, at least in animals, it's a bad thing. So here's some examples of non-disjunction. So they would lay out this karyotype. So basically they take a picture of the chromosomes, they sort them out. They generally actually cut out the chromosomes and they paste them there. That's why they kind of look kind of funky on this picture. So our number 1, as you can see, is the larger one, and then it moves across. So the first question that we always know from non-disjunction is the gender. That's easy to see. You look down here at sex chromosomes, so the last set put up. Here we've got 2 large equal-sized chromosomes. Those are going to be the X chromosomes. Therefore, this will be a female because females have 2 X chromosomes. The next question, is there any genetic disorders? If so, where do they take place? So we got to look and say, okay, there's 2 number 1s. That's what's supposed to be there. 2 number 2s, 2 number 3s, and we keep going. Normally, if there's any problems in these large chromosomes, in the first 12, basically you're going to have a child that's not born for the most part. Some of these smaller ones, you can have some extras and missing, and the child will be born, but they'll have some serious birth defects. So if we look down here, though, we can see there is 2 in every spot. So then things are great. There's no genetic disorder. The child will be fine. Here's another one, though. So let's take a look at that, see if there's any issues here. Again, what's the gender of this person? Well, we look for the X and Y. Well, here now we have a really big X by itself and a little dinky Y. And so we know that if it's XY, it's going to be a male. So now we look, is there any genetic disorders? So now we're counting chromosomes again. 2 number 1s, 2 number 2s, 2 number 3s, 2 number 4s, 2 number 5s. 6, 7, 8, 9, 10, 11, 12 are all the same. 13's fine, 14's fine, 15's fine. 16, 17, 18, 19, 20, all 2. Then we get to 21, and you'll notice there are 3 chromosome 21s. That's as genetic disorders go, that is a survivable one, but that is where it is. So we have 3 21s. That child will be born with Down syndrome, which is probably the most common non-disjunction that we see that causes birth defects. But this one, the child will survive for a reasonable length of time. Another example, what's the gender of the person? Well, we've got an X and we got a Y. Next question says, are there any genetic disorders? If so, where? Well, we got a Y, and clearly there's only supposed to be one X if you got a Y. So this is a male because they are Y, even though they got 2 X's. If you have a Y, you will always be male. That's what goes on there. Unfortunately, there's 2 X's, so that can cause some issues. They're generally pretty minor. We seem to be able to survive all sorts of different sex chromosome issues. There's females with 3 X's. There's males with an X and 2 Y's. There's XXYY. They're all fairly survivable. There might be some residual problems, but for the most part, they're fairly minor. In many cases, like in this one, they will not reproduce. Other than that, they are generally fine. There might be some minor problems. There's only one that we'll see that there's 1 X and no Y, which is called Turner syndrome. That can cause some more significant problems, but still it is a survivable situation. All right, so that ends our examples, but that's what we're looking for when we look at non-disjunction. So as you do your online activity, keep that in mind. We're looking for the X and Y to see, is it male, is it female, and to make sure we have 2 of each chromosome. Another thing they might look for is some of these chromosomes get broken and parts are missing, or sometimes they'll be moved to different chromosomes, and that can also cause genetic disorders. But that goes into more detail than you need to know at this point. Take my genetics class and you'll learn more about that. All right, so that ends these notes. I hope you learned something. If you have any questions, please let me know. Email me, or we can talk later on. That's it. Goodbye.